All right, today we're learning about surface area and volume of similar solids. Similar. So because they're similar, I can use proportions. That's what kind of the common theme is in the lesson today. But it would not be the last official lesson of the book unless we made an announcement that it is. Are you guys sad?
No. Yeah, very.
So sad. All right, it is. So after today, tomorrow we review for your quiz. Friday, you quiz over chapter 10. Then next week, we review, test, and then we start our final exam review. All right, so those packets are already in printing. Yes.
We got test next week?
Yes, you have chapter 10 test next week. All right, okay, so in example 1, I'm going to explore which solid is similar to cylinder A. So the most important, idea here is that we set up a proportion comparing the same unit on both sides of the proportion. So with cylinder A, I'm going to write a ratio. I'm going to do the radius over the height. Radius over height. I could have done height over radius. That doesn't matter as long as it's the same thing on both sides. All right, so radius over height equals, now I'm going to compare A and B, equals radius over height. I need to do cross products. Now, this is something that we did do earlier in the year in chapter 5. But when I do cross products, if my totals are equal, then they are in fact similar. So 6 times 3 is 18, and what's 5 times 4? 20. So A and B are not similar. A and B are not similar. So let's compare A, 6 over 4, and C. So remember, we did radius over height, so we must do radius over height. And just like with the other sections of chapter 10, I will allow calculators on this test. So you can use a calculator to do 4 times 7.5. And then you don't need a calculator for 6 times 5. 6 times 5 is 30. And 4 times 7.5 is also 30. So because those totals equal, I know that cylinder A and C are similar. I will use proportions in this entire lesson. I'm going to use proportions to prove whether or not solids are similar or to find unknown dimensions. All right, we're using proportions. All right, example 2. So I'm going to use similarity. The fact that they are similar. So the instructions tell me these cones are similar. So what I'm going to do is set their ratios equal to each other. So you can do slant height over radius or vice versa. I'm just going to do radius over slant height. So for cone X, what is my radius? Y'all talk to me. 5. And what is my slant height? 13. So I just have to write them in the same order for cone Y. What is my slant height for cone Y?
7.
Nope. That's a cursive L.
Oh, we ain't got one.
Okay, we don't have one. And then what is my I'm sorry. I wrote it the wrong way. I did radius. So radius is 7. That's why you said 7. Over the slant height that I don't know. Okay, that's about the only way you can get this wrong. So don't do that. All right, so now I'm going to do cross products. 5 times L and 13 times 7. 5 times L is 5L. 13 times 7, well, I know 12 times 7 is 84. Plus 7 is 91. Divide both sides by 5. All right, this is going to be a decimal. Not a big deal. The slant height for cone Y, what is 91 divided by 5? 18.2. And there is a dimension yards. That's it. That's it. Proportions is the key. If you set up your proportion correctly, you're home free. Okay? So you just have to set up that proportion comparing the same unit on both sides. All right. So I want you now to do this one. So you're going to have to, well, let's do the first one together and then I'll let you do the second one. So we have 3 dimensions now on this rectangular prism. We have the length, the width, and the height. On the small one, I don't know the length or the width, but I do know the height. So you can't solve for 2 variables at one time. So you're going to have to do one proportion and solve for length, and then one and solve for width. Which dimension do you know both of on both figures? Which one? I heard it. Say height. I know the height. What is the height of the big one? No, the big one. 20. Okay. What is the height of the little one? Okay. So I'm going to say, really, I could do this either way. On the last one, I stayed within the same figure. So we'll go height first. So the height is going to go on top. Okay, so I have height of the big one and height of the little one. Now on the bottom, you just pick. Do you want to solve for length first or width? What do you guys think? Maybe length? Okay, so for the big one, what is the length on the big one? Right there on that front side, 11. But I don't know the length of the little one. Do you see how I did that? So I went height over length. So when you solve for width, what do you think you're going to do? Height over width. All right, you guys go ahead and finish. Once you have an answer, I do want you to turn to a neighbor and compare your answer with your neighbor. Okay, cross products. Did you get 20L equals 88?
Yes.
Did you divide both sides by 20?
No.
L equals 4.4 inches. Did you guys label? Did you write inches? Talanda, stop. All right, someone raise your hand and tell me what proportion did you set up to solve for width? Okay, so you did 20 height over width. Okay, so height over width equals, what is the height of the little one? 8 over W. Now, many of you had not finished solving this one, so I want you to go ahead and finish solving this proportion now to solve for W. Okay, 20 times W is 20W. 8 times 8 is 64. Divide both sides by 20. W equals what? 3.2 inches. 3.2 inches. All right, thumbs up if you got it. Did you guys get it? Okay, very good. All right, so here, this one, y'all have this image, right, on your notes? Okay, so this picture, here's why I put this in your notes. This one actually is really helpful, okay? This shows you 5 different solids all in one picture and which dimensions are located where. Look at the first one. What kind of figure is that first one? It's a cube or a prism, a rectangular prism. Could be a square prism. If I had dimensions, I would know. What's that second one? It's a pyramid. What kind of pyramid? A square or a rectangular. Look at the base. The base tells me what kind of pyramid. All right, what about that third figure? Cylinder. What about the next one? Cone. And what's the last one? A sphere. So all of these solids are 3-dimensional. So I can compare any one of them. I can compare prisms, pyramids, cylinders, cones, or spheres. As long as they are similar, I can solve for their surface area. And this is my formula. I will, in one ratio, have my surface area of my figure A and my surface area of my figure B. In the other ratio, I will put some kind of dimension. They have to give me something. Usually it's the radius of each. And then here's the kicker. I got to square it. All right, you paying attention? So here's the example. What do I have here, guys? Pyramid. Okay. So again, I'm going to use my formula to solve for an unknown dimension. Says the pyramids are similar. What does it ask me? What is the surface area of pyramid A? All right, so here we go. I don't know the surface area of pyramid A, so I'm going to plug in an S for pyramid A. What is the surface area for pyramid B? 600. Equals, all right, so I can see clearly here in the images, it gives me the height. So what is the height of pyramid A?
6,
And what is the height of pyramid B?
10,
Okay, now I have to square it. Let's see if they reduced it. All right, they don't reduce it. So we're going to leave it like that. And we need to square now the fraction. S over 600 equals, what is 6 squared? 36 over, what is 10 squared? 100. Now you're just going to do your cross products and solve it the same way. So we have 100 times S and 600 times 36. Yep, it's going to be a big number. 100S equals, all right, so 21,600. So I can divide both sides by 100. Do not use your calculator to do this part of the division. You don't need it. To divide a number by 100 means that you move the decimal left 2 places. So what is the surface area of pyramid A? 216. Make sure you label feet squared. It's all about proportions. If you can set up your proportion, you're good to go. Yes. Okay, now let's do volume. Volume is set up the exact same way, except volume is the capacity, which takes 3 dimensions. Surface area is the amount to cover a figure. That's 2-dimensional. So for volume, we have 3 dimensions. We're still going to put the volumes in a ratio. We're still going to put one of their dimensions in a ratio, but now what does that 3 mean? I need to cube it. So that's going to be the only difference between surface area and volume. I'm still going to set it up the exact same way. It says that the cones are similar. Remember, any one of these figures, cones, spheres, cylinders, pyramids, I can be comparing them. In this case, I'm comparing cones. What is the volume of cone A? So I'm not going to know cone A. I'm going to do a V for volume for cone A. What is the volume for cone B? 288. Equals, what dimension am I given? Height. So what's going to be my ratio on the other side? What would you guys say? Just tell me. 5 over 12. But now am I going to square it? No.
No, you're gonna. Oh,
I'm going to cube it. I'm going to cube it. Okay, so V over 288 equals 125 over, and then we need to do 12 times 12 times 12. I'm pretty sure I know what it is, but I just want to double check.
1,728.
Yep, that's what I thought. 1728. All right, now I'm going to do my cross products, and I'm going to solve it. It is going to be big. It's going to be a big number. I have 1728 V equals 36,000. Now I solve for V. Divide both sides by 1728. That's okay. What do the instructions say? Round your answer to the what? To the nearest tenth. So I get 20.83. One thing that surprised me on the quiz yesterday, guys, how many people made rounding mistakes? All right, there were a lot of rounding mistakes. The tenths place is the first decimal value after the decimal. So 20.83. The 3, does the 3 keep the 8 the same, or does it raise it up? It keeps it the same. So it should be 20.8. Technically, I should have done my squiggly equal sign because I rounded it. Centimeters cubed. All right, so I used their similarity. I set up a proportion, did my cross products, and solved for V. That's it. All right, guys. That's all you need to know for section 10.4.